And if you have, if you want to know whether or not you get the correct answer, look it up at the end of the textbook and for answers there. And if you have questions, make sure you talk to me. You see me every day, Monday through Thursday there, and we can definitely find some time and talk about whatever questions you may have. Okay. And also about the final exam, if you click on Canvas there, when you click when you open Canvas, when you click on the final exam, there is a document. I think the title is Information Sheets for the final exam. Now you are allowed, and that if you open that document there, you will see that's everything that will be provided to you, in addition to whatever American Chemical Society gives you. I can tell you they're not giving you a whole lot. They give you a periodic table. We also give you a periodic table. And in addition to that, they just give you some constants, some of the constants that you will be using for taking that exam there. So I figured throughout the semester for the 3 in-class exam there, we give you all that information, including the conversion factor and all that. So we will also provide you with that information. So open that document and take a look at what's in there, what's given to you. In addition to that, each person is allowed to bring in an index card filled with whatever information you feel necessary for the final exam. So it's a good time for you to start preparing your that index card for yourself. And you know yourself the best, and you know which part you haven't memorized yet, or you know which part you don't want to memorize, and you can put that information on the index card. And so each person is allowed to bring in an index card with information, whatever information you deem necessary for when you prepare for the final exam. So that's another information I want to give you early on, so that you can start preparing for the final exam. Okay, and we will continue our discussion. Chapter 9, Chapter 10, those are the 2 chapters that's also going to be covered not on the 3rd exam, but in the final exam. Okay, so you will see questions related to Chapter 9, Chapter 10. And when we start Chapter 9 there, I would expect you to start working on the homework assignments in Chapter 9. Those are the questions on homework number 3. Now the homework number 3 due date is next Thursday. And it covers Chapter 9, 10, 11, 12, and 15. Now, we will probably still be talking about 12 and 15 on Thursday. So there's no way that you can finish all the questions in the last 3 chapters. And the least amount of work that you need to do on homework number 3 is to finish all the questions in Chapter 9 and Chapter 10. 11, 12, and 15, do whatever you can. And if you don't do any of those 3 chapters, questions in any of those 3 chapters, you're fine. But you need to do Chapter 9 and Chapter 10. Okay, so throughout the semester, we've been talking about what chemistry is all about. We've been talking about chemistry. We're trying to study the behavior of matter, understanding the behavior of matter by studying the behavior of atoms and molecules. So the key thing here is that in addition to the stoichiometry, all the definitions there, quantum theory, quantum numbers for electrons, well, we've been trying to understand how are the electrons being distributed. Now, electrons are being distributed in different atoms in different ways. What happens then if 2 atoms combine together and form a molecule? What happens in the process of chemical bonding? And that's going to be the topic for the next 2 chapters, Chapter 9 and Chapter 10. So you see the title in your textbook there, Chemical Bonding number 1. We're talking about the Lewis model. And we are going to be focusing on what we call the covalently bounded molecules, or molecular compounds. And we're trying to understand how are the electrons being distributed between 2 atoms if you have diatomic molecules, or among a polyatomic molecule where you have multiple atoms involved in there. So this is going to be the focus. We need to understand, now that we know how the electrons are being distributed in a particular type of atom, atoms of a particular element there. And if you have different types of atoms connecting with one another and forming the chemical bond, what happens to the electrons that those 2 atoms have? And, are they going to share them, or is there a transfer of electron from one place to another? So that's going to be the topic for the next 2 chapters there. We're going to looking at when atoms are no longer staying by themselves alone, when they start to combine with one another, what happens to the electrons? And once again, understanding the electron distribution is the key to understand the chemical behavior. So in order to in order to understand how the electrons are being distributed, we have to look at what we call the chemical bound. Okay, so we have ionic bound. Early on this semester, we talked about ionic compound, we talked about molecular compounds, and we even covered the nomenclature on those ionic compounds and molecular compounds in chapter 3. So we will look back to see what is ionic compound, what is molecular compound, what are the chemical bounds, what are the difference about the chemical bounds in those different types of compounds there, and be able to identify compound as either ionic or covalent. Now this topic is kind of a review that we have had. We have talked about for the material that we have talked about early on. So the first learning objective, we're going to look at these different terms there. So talking about the chemical bounding, and when you have two atoms combining together, whether in ionic form or covalent form, and we have to think about all of these things there. When chemical reaction happens there, what holds the atoms in a molecule or ionic compound together? Well, by nature, ionic bounding, covalent bounding, by nature, both are electrostatic. And it's the positive charge, negative charge being attracted to one another. Okay? And also when you look at the structure of the molecule, and atoms in a molecule often are distributed at a particular angle. What is the reason for that? Why can't they just cluster together? Why can't they just form a straight line? Why can't they just form why do they take all that particular angle there? And that has something to do with the electrons involved in chemical bounding. And also molecules, most of molecules are not two-dimensional, they're three-dimensional. They take up the space there. And what is the reason behind that? And also, how can we predict the structure of the compound? And how does the structure relate to the chemical and physical property? All of these things have something to do with chemical bounding. And talking about the chemical bounding definition, chemical bound is the attractive force holding two or more atoms together. Okay, and that's what's happening there in terms of the chemical bound there. And now we do have different types of chemical bound. Covalent bound, we mentioned this term there. Covalent bound is the result of two atoms, non-metal atoms, sharing electrons. Okay, and the key word is sharing. And you can see covalent bound atoms are nicer to each other, and they are willing to share. Ionic bound, and it's electrostatic in nature, well, so is covalent bound, but just the thing here is that there is no separation of charges there. Ionic in covalent bound molecule, but in ionic bound, there is a positively charged ion, there is a negatively charged ion. So there is a transfer of electron going from one species, the metal, to the non-metal. So you will have cations and anions in chemical bounding. Another type of chemical bound, we call it metallic bound. Metallic bound is the attracting force is holding pure metals together, where, well, in the metal elements there, in the atoms of metal elements there, electrons can move freely. Well, that's why metals are good conductors. Okay, and the electricity will go through because of free flow of electrons there. So in a sense, you can imagine the metallic atoms there, well, metal atoms there, there are fixed number of positive charges, and then the electrons can go from one place to another. So the positive charges are submerged in the sea of electrons, where the electrons, like water,